Good morning, good afternoon, or good evening, everyone. I hope you are doing well today, and welcome to the second part of Unit 9, which is called Machines. Before we go any further, we're starting a brand new unit, which means we have a brand new set of objectives. Please pause the video and take a moment to read over those objectives for yourself. When you're ready, press play and we'll move ahead. Alright, the first part of this new unit is called Machines Part 1. We'll divide our lesson on machines into two parts because there's quite a bit to talk about. And then the final lesson will be called Simple Machines. So let's jump right into Lesson 9.4, Machines Part 1. So what is a machine anyway? Well, a machine is any device that makes work easier. That's the very basic definition of a machine. We'll talk about several different types of machines. You might be thinking of a machine like a car or even a computer, and those can certainly be considered machines, but I'm thinking of much simpler types of machines. Things like bicycles, baseball bats. You might be like, how is a baseball bat a machine? Well, we'll talk about it as we move through this unit. So what does a machine do to make work easier? Well, a machine can either change the size or the direction of the force that is needed to do a job. Let's look at some examples. Consider this pair of adjustable pliers. If you input a small force on the handle, the head of the plier will output a large force. If you've ever been foolish enough to stick your finger into the business end of a pair of adjustable pliers while squeezing the handle, you know that you get a very large force here and it hurts quite a bit, even if you only squeeze a little bit here. So, pro tip, don't do that. A hammer increases the amount of distance traveled by the head of the hammer when you move the handle a very small distance. So basically it causes the head to be moving at a faster speed so that when it hits the nail, it exerts a large force that drives the nail down into the piece of wood or whatever it is you're trying to hammer into. And a bicycle, well, changes not only the size of the force, but also the direction. You push down on the pedals, and the tires of the bicycle push back against the pavement, which, by Newton's third law, means the pavement pushes forward against you and causes the bicycle to move forward. Now, before we go any further, it's very important that you understand machines do not multiply work. In other words, a machine cannot output more work than what you put into it. If you put 100 joules of work into a machine, the machine cannot output 200 joules of work. Okay, that would be a miracle if that happened. Machines actually always output less work than what you put into them. And that's because of friction, because parts of the machine will bend, which absorbs some of the energy that's being put into them. So anytime you use a machine in real life, you get less work out. But wait a minute, why would you use a machine if it just gobbles up some of your work and doesn't give you the full output? It's because even with that happening, it still makes the job you're trying to do easier. Remember, a machine is not about outputting more work than you put into it. It's about taking the amount of work that you have to do and making that work easier by having to use less force or being able to apply the force in a direction that is more convenient. So we're going to wrap up this lesson by talking about four quantities that will come up when we're doing problems involving machines later in this unit. And that's going to be the effort distance, the resistance distance, the effort force, and the resistance force. Distance and force are abbreviated D and F, and we attach an E or an R to indicate which type of distance or force we're talking about. So we're going to go through each of these very quickly, and as we do, we're going to discuss this situation where this guy, we're going to call him Frank. Frank is pushing a box up a ramp. A ramp is a type of machine for reasons that we will discuss later on. Now, this ramp is 5 meters long and 2 meters high. The box that Frank is pushing weighs 400 newtons, but Frank only has to exert 200 newtons of force to push the box up the ramp. If he tried to lift the box straight up, then he would have to use 400 newtons of force. So the ramp is making Frank's job easier. It is easier for him to push the box up the ramp than it would be for him to lift the box straight up. So let's start with the effort distance. The effort distance is the distance that you must apply force when using a machine. In this case, Frank has to push the box 5 meters up the length of the ramp in order to get the box to the top here. So in this situation alone, the effort distance is equal to 5 meters. The resistance distance is how far the machine moves the load. While Frank has to push the box a distance of 5 meters, the ramp only raises the box 2 meters. So the resistance distance in this case is 2 meters. Once again, the effort distance is 5 meters. The resistance distance is 2 meters. The effort force is the force that you, or Frank, must apply when pushing the box up the ramp. It doesn't matter how much the box weighs, the force that Frank is inputting is 200 newtons. So in this situation, Fe is equal to 200 newtons. And finally, the resistance force is the force that the machine has to use to move the load. The resistance force and the resistance distance will usually be in the same direction, in this case up and down. And the effort force and the effort distance are usually in the same direction, in this case along the length of the ramp. So that's how you can tell them apart. The resistance force is very often equal to the weight of the object that's being moved. So if the crate weighs 400 newtons, then the ramp must apply 400 newtons of force to lift it up to the top of the ramp. So the resistance force in this case is equal to 400 newtons. So that brings us to the end of lesson 9.4. We have learned the major components or quantities associated with machines. Please hop on over to Google Classroom. I have a very short assignment waiting for you there. Take a few minutes to finish that up and contact me if you have any questions. As always, I hope you're taking care of yourself. Continue washing your hands, be safe, and check in tomorrow when we will go over lesson 9.5, which is Machines Part 2. And we will talk about some more quantities associated with machines and how to calculate them. So be sure you bring your calculator with you tomorrow. Until then, take care. Have a great day. Bye.